Do you want to go for a drive?
Yeah, sure. Actually, that reminds me of some research I was doing for my uni course.
Really? What was it about?
I was looking at some time series analysis of the fatal car accidents in Australia.
Oh, and that makes you want to go for a drive.
Only if you're driving.
What was it about?
Well, so I was looking at the government data based on monthly fatal car accidents in Australia between 2009 and August of this year.
So why do you want to do that research?
Well, every time a fatal crash occurs, a family or more lose a loved one, and by understanding the data and seeing the trends, we might be able to decrease or even prevent some of these instances.
Alright, let's go for a drive.
Sure.
So what'd you find then?
Well, by looking at the data set by itself, it didn't actually reveal a lot in the way of trends because there were very sporadic maximum and minimum points that didn't seem to have much relation to each other.
Right, so what does that mean then for patterns in the data?
Well, it just means that there were no indicators of seasonality, autoregressive, or AR, and moving average, or MA, behaviours.
Did the month tallies have any relation to each other? Like, did 1 month's tally, was it affected by the previous one, or did it affect the next one?
Well, I was looking at some correlative analysis for the dataset, using 1 month's tally and comparing it to its previous month. This actually didn't show much of a significant link, as there was only a very weak negative relationship between the two.
So then what'd you do?
I moved on to the autocorrelative functions, so ACF, and then the partial, PACF. And these both showed for 3 significant lags that broke the confidence intervals.
What's a confidence interval?
Well, in this case, it helps as an indicator for a stationary mean, and with no major patterns in either the ACF or PACF, it means that there is highly unlikely of there being a trend in the data.
Oh, do you want to keep going?
Yeah.
Cool.
So after all that was done, then we had to make sure that the data was normal and that the mean was stationary.
How'd you do that?
Well, we did that by using the Sharper-Brooke test to test for normality. Then we used the augmented Dicker-Foley test to make sure that there's a stationary mean. And then as how, we used transformations of the data.
Oh, which transformations did you use?
Well, we used the box code, square root, logarithmic, and the exponential transformation. But we ended up using a turkey transformation, as that gave us the highest probability of approaching normality.
Right, and what did that lead to?
Well, after that, then we can begin to model the data and start some parameter estimation.
Right. How'd you model it?
Well, by using the ACF, PCF, EACF, and the BIC tables of the first difference of the transformed data, then we can begin to create a candidate set of models that we can use to fit the data.
Oh, yeah. Which candidates did you use to fit the data?
Well, we ended up with a range of models from the ARI MA set, and once we fit those, we can begin to forecast.
Forecast?
Yeah, so once we've fitted the model to the data, we can extend the range in which it exists to predict further values. So once, for this assignment, I decided to use 12 as my prediction length, because if we're using one for each month, then we're predicting a full year of fatal tallies.
And what did the prediction show?
The prediction showed a rather stable, a rather stable tally for each oncoming month, all saying around the 90 range. with no major increases or decreases.
So, all in all, what can you say about your results?
Well, besides the two issues of the data having no real existing trends and the transformations being unable to perfectly reach normality, the results should still be able to accurately predict the monthly fatalities in Australia with some degree of error. So this means that there shouldn't be too large an increase or decrease in the monthly fatalities for the next year without major intervention by authorities.